Constantino, do you want to unmute yourself and tell me which one you want to look at?
It was the last one on this assignment.
Okay.
The one way.
Okay. Last one. What we're going to be doing right now is 2.4 2D forces diagram tutorial. The 2D forces diagrams, the tutorial on it, and you want to do this one. Woo! Yeah, this one's kind of vicious. All right. Constantino, do you know how to mark up a document?
Me and Max were using Microsoft
Whiteboard? That's cool.
Yeah,
You
we
can
were
just
using
take a picture of it and then save it as a PDF. It works. I'm going to mark it up right in here. Okay. And in fact, you know what? Since you mentioned Microsoft Whiteboard, I'm going to copy this. We're gonna all work on this together. So I'm going to snip it. So you go to everybody who has a PC has a snipping tool. And you could snip whatever you want. And again, we're doing 2.4, the lecture tutorial. And I'm going to open up Microsoft Whiteboard. I'm going to copy the link. If you guys want to click on that link, we could work together and do it. Somebody just jumped on. So do me a favor. Somebody go ahead. Whoa! Back out. Back up. Back the bus up. I'll back it up for us then, I guess. Okay. Remember, everybody has the opportunity to make this as great as we possibly can, so we're going to do that. Somebody want to go ahead and write what's the first vector we always write on the vector diagrams? So let's have you guys. Let me do something. I'm going to put a coordinate system. So somebody's drawing something. Make sure you label whatever vectors. Don't forget, always remember to subscript it too. And don't click on the actual picture, guys. Okay, perfect. That's awesome. I'm going to write the coordinate system over here, just so we're clear. There you go. Good. Perfect. Okay. So now think about, let's just work on the 4 kilogram object right here. What is physically touching the 4 kilogram object? What do you guys think? Go ahead and unmute your mic and chime in. Right.
The hand is.
So the hand.
So, force
yeah.
hand.
Cecilio just said the hand. Go ahead and somebody, and then also there's a normal force, right? And something else is, so the surface of the ground is the normal force pushing up on it. The hand is pushing it to the right. And
then the other block?
Yeah, the 2 kilogram block is on its right-hand side. And remember, objects will push on you, right? So a flat object that's inanimate is going to, in this case, is going to be pushing on the 4 kilogram block. Don't forget to subscript. It's a normal force acting on A. Right? So somebody draw the hand force and start drawing stuff. So the block, the 2 kilogram block, is working against it. And somebody's drawing a green arrow over here. That should be to the right, and that's the hand force. If you ever draw a vector, you got to label it. Here, is it okay if I straighten that? Guys, there's a straight edge if you need to use it. There you go. The 4 kilogram block is pushing the 2 kilogram block to the right. Going to make the angle a little bit smaller. So while we're here, so I'm going to label that a tension force. And we're going to break that up into up and down and left and right. And that's a tension T of 6 newtons, by the way. And that hand force over here was 15 newtons. Somebody want to go ahead and label this and the horizontal and vertical vectors of that tension force in terms of theta? Lisa, you can I help whoever is doing, who's CM? Is that Cecilio? I'm gonna go ahead and help you with that.
Oh, Jim, that's me.
Oh,
Yeah.
Okay. We're not going to put in the numbers just yet. Put in the numbers last. It's a good trick to get in the habit of it. And I erased part of that vector. So here's the force. Wow. Here's the force diagram for that. And I think the problem is asking to do to sum the forces on both of them. All right.
Yeah.
All right. Let's, over on this side, we're going to sum the forces on the 4 kilogram block in the x direction.
Is there no friction?
I'm sorry, say that again?
Is there no friction in this problem?
That's a good question. Let me read it.
The friction is on top of the picture of the two blocks. It's 0.2 kinetic
Oh,
friction.
yeah. Yeah, there is friction. Good catch. So that means friction force is going to be working to the left on the 4 kilogram block. It's going to be resisting the motion, mu sub k times the normal force on block A. And it's also going to be working against the 2 kilogram block, normal force of block B. Remember, if the object is moving to the right, and I don't know which ways it's accelerating, but anyways, if it's got a velocity vector to the right, and it does, then that means friction is going to be pointing opposite that direction. Kinetic friction will tend to slow stuff down, try to slow it down. Okay? Nice catch. Wonderful. All right, let's go ahead and do it. So what I'm going to do is I'm going to go ahead and sum the forces, horizontal forces here. I'm going to write I'm going to write the hand force. It's to the right. It's the blocks touching each other is to the left. And it looks like the frictional force is also pointed to the left. And that's going to be equal to block A. Actually, block A times its acceleration in the x direction. Somebody want to try to do the y direction forces on block A? So this is the 4 kilogram block is block A.
Jim, I can't find the link. I tried to check the link, but I can't find it.
I could grab it again. It's up a ways. It's right here. I just reposted it. So somebody want to try summing the force on the 4 kilogram block in the y direction?
I will.
Okay, that'd be great. Do it right there. Are you writing with your mouse?
I'm using my top, so
Yeah, it's tough to do it. Yeah, that's right. Do you mind if I write over it to try to make it a little bit more?
sure.
I have a pen, so it's probably
Yes.
easier for me. But yeah, that's exactly right.
I love that. I love that.
It's exactly right, Constantino. Is perfect. MA times G equals MA times the acceleration in the y direction. Notice the acceleration is only in the x direction. That means this is going to be 0. And that we could say this. In this case, we could say this, right? N sub A minus M sub AG equals 0. So you could say this. That means this guy right here, we're going to use this to sub in right here. Okay. We don't know what this force is, so we have to use the other equations to solve for it. Okay. So what we're going to do is sum the forces in the x direction on the 2 kilogram block, or block B. So let's go ahead and try to do it here. It looks like the 4-2 contact force is pointed to the right. And we've got a t cosine of 30 degrees pointed to the right. And that is going to be equal to the mass of B times, oh, I forgot friction, minus mu sub k times the normal force on block B. And that's equal to mass times acceleration of block B in the x direction. And summing in the y direction, you're going to have, I think, t, what is that? Does somebody want to start this one? Somebody else do this one. Anybody want to give it a shot? There you go. Thank you. Gonna lasso some of this stuff up. I'm gonna help you clean it up a little bit. And again, this is 0. And the whole point on doing this stuff right here, the y direction stuff, is to get the normal force. And in this case, it would be mbg minus t sine of 30 degrees, right? And really, Constantino, this is fine for that worksheet. You don't have to actually get the acceleration, right?
Are you serious?
Yeah. If you could write this stuff, I mean, we'll do it right now, but I'm just saying that this is perfect right here. Okay. But let's, because this is a really, really complicated problem.
Because me and Max solve it for acceleration and solve it for all the stuff it was.
Well, let me show you the reason why I'm good with you not doing that. Because when we write out this problem, we need to solve for this, right? And then we're going to plug it into here, right?
Mm-hmm.
So we're going to take this entire equation and plug it in for here. Let me show you the reason why I want you to stop on the problem after you've got this stuff written out. Because plus t cosine of 30 degrees minus mu sub k, and that normal force is this whole thing, right? So Constantino, and you're actually helping me alter that worksheet. So I'll alter the requirements.
As after Max for them, Max asked Megan if she could check out work. She sent us you got me and Max rolling off by like 0.2 of answer. Me and Max.
Yeah, it's right. So so that 4-2 force, I've got to bring it out over to the other side. And I'm just doing algebra, so I'm solving this for F42. So that means I'm going to bring t cosine of theta onto the other side by subtracting it from both sides. And I'm going to add this whole thing to the other side. Right? And so now, after I've got that, I've got to plug this force into right here. And so what this becomes, it's starting to look like Frankenstein's monster, right? So I'm going to plug in this entire thing right into here. It's looking like it's turning into a monster slowly. It's probably saying, kill me. Okay. Times the normal force right here, but the normal force is just MAG equals MA times the acceleration in the x direction. Now we have to solve for the acceleration in the x direction. That means we got to multiply a negative through. That's a positive. Yeah, we're going to talk about the tests, Joshua, in a little bit.
Wow. My God.
This is the reason why I was like, yeah, you're good just doing the and we're not even done. I got to bring this over to here. Okay. It's screaming, kill me. Just let me die. Okay, hold on. Here we go. So I'm going to add this to both sides, right?
Wow.
And this should be MBG minus t cosine of 30 degrees minus mu sub k MAG equals, and I'm going to move this down.
I'm not gonna lie, when I did this, I just left it blank.
Yeah, I don't blame you. Because that's
all the
what
work.
I'm doing.
Not worth it.
I just brought this to the other side. And then we have to pull out a sub x. So this whole thing, it goes right here. And then pull out an a sub x, and you get MA plus MB. And then to get a sub x, I got to divide this whole thing. So basically, this is your answer. And it's just that easy. This is like whenever I watch a cooking show. It's just that easy. become a professional cook.
Yeah, after this part, I felt confident in myself for taking statics next semester. So.
And there you go. I mean, that is obviously the answer to this.
Hard.
Center this. And there you go. And just plug in your numbers. And the answer is like 5 or something.
What? We got 2.724.
Or it's 2.724. I don't know. But guys, I want you to just do this part in that worksheet, and I'll adjust that worksheet's requirements. You know,
Is that for all the questions or for this one?
just this one.
Okay.
This one's difficult, to say the least. So yeah, I'm going to have you guys just, if you could do the force diagrams and then put in the forces, I'm going to delete this part right here. In fact, I'm going to do that right now. Sorry, Constantino. Sorry you went through all that.
A little too late. I wish it was already done that.
The Constantino.
That's how good, Jim.
No good deed goes unpunished, Constantino.